All right. Good morning or afternoon, everyone. Happy e-learning day. Today we're going to be graphing linear inequalities. So there's a couple of essential review problems at the top. Remember to determine if x equals 5. To determine if x equals 5 is a solution to the inequality, we take x equals 5, we plug it in for x, and then we solve. Once we solve, we get a is less than or equal to 6. Since that is not true, we say x equals 5 is not a solution. All right, so this is just some essential skills review from what we've already done because we're going to need this information to help us today with our notes. Number 2, we had to graph the equation. So remember, the first thing that we do is we solve. We put the equation into y equals mx plus b. We solve for y, so we're going to have to add x, opposite operation, to both sides. 2y is equal to x plus 2. Then we have to divide everything by 2, and that gives us y equals 1/2 x plus 1. My slope is 1/2, my b is 1, so I can plot 1 on the y-axis, count my rise over run, up 1 over 2, plot my points, and draw my line. And your graph should look like that. All right, make sure that your graph has a positive slope. It does. It's positive slope here, so I know that my graph is correct. All right, looking at the key vocabulary. Linear inequality in two variables has to have an x and a y. Okay, your two variables are x and y. They can be written as y is greater than mx plus b, y is less than mx plus b, y is greater than or equal to mx plus b, and y is less than or equal to mx plus b. Okay, those are the four options that we have, very similar to just y equals mx plus b, except we have our inequalities in there. A solution of a linear inequality in two variables is an ordered pair that makes the inequality true. Okay, so remember, we need sum, comma, x, comma, y. We need an ordered pair that makes the inequality true. So if we look down here below, tell whether the ordered pair is a solution of the inequality. So remember, we have an x and we have a y. X is -1, so I'm going to plug it in for the x value. So 2 times -1 plus 9 is less than -3. 2 times -1 is -2 plus 9 is less than -3. So 7 is less than -3. Is that true? No, that is not true. So we can say -1 comma 9 is not a solution. All right, so go ahead and try problems 2 and 3 on your own. So plug those in and see if they work. So you can pause the video for a second, try those out, and then see if you get the correct answer. The only way this is going to help you is if you actually try it. You can copy everything that I write down, but it's not going to help you learn. So the best thing is to pause the video, try it out, see if it works, and see if you get the same answers that I do. All right, so number 2, you should have got 2, -2 is a solution because 8 is equal to 8. Remember, this is greater than or equal to. So the or part, equal to, is the true part. So that makes that a solution. And number 3, -1, 3 is also a solution because -7 is greater than -8. Remember, -7 comes before -8 on the number line, so it is the bigger number. All right, so you should be able to plug those in and solve for the variable, or to solve to see if it is a solution or not. All right, looking at the next part, how to graph linear inequalities. Graph the line that represents the inequality. This is called the boundary line. The boundary line is this line up here that we draw when we're graphing. This is a boundary line. So that's a graphing line, that's a boundary line. All right, we are going to make a dashed line, so it's going to look like this. A dashed line for the inequalities that are greater than or less than. That means that It does not include the points on the line. So if we're checking for a solution like we did up here, negative 1, 9, that's not a solution. That means that it's not on the line or in the shaded area. Okay? So this dashed line, you cannot include the points on the dashed line, kind of like your open circle and closed circle. Open circle does not include the points on the line, but a closed circle does. That's the same with dashed. Dashed does not include the points on the line. All right, a solid line is just going to be your normal solid line like we have been drawing. And that has your line underneath. That means it includes the points on the line. So it's greater than or equal to, or less than or equal to. Line underneath, solid line. No line, dashed line. All right, now for the shading. If we shade above, that's all the values that are greater than or equal to. Make it make sense. Above means bigger, so those are greater than or equal to. Below means less than, so these are less than or equal to. So when we shade, we are just shading the line, the area that is below the line, or we're shading the area that is above the line, depending on what the inequality says. So if we look over here to y is less than or equal to negative x minus 4, first thing I'm going to look at is the less than or equal to. Less than or equal to is going to be a solid line. So I'm going to write it solid because it has the line underneath. And it's less than, so it's going to be shaded below. So these are the two things that I'm going to write, solid and below. Now I also know that my slope is negative 1 or negative 1 over 1, and my y-intercept is negative 4. So now we're going to graph it. I have to start at negative 4 on the y-axis. I'm going to count my slope, down 1 over 1. We're going to fill up the graph as much as we possibly can. So I have to do opposite to get the other end of the graph. Okay, and then I look. It's a solid line, so I can go ahead and draw my solid line. And now I need to shade. So you're going to take your pencil. I'm going to use my little highlighter pen on here because it's easier. Okay, you're going to take your pencil and you're just going to lightly shade, okay, the below, because this says below the graph. So if I think about what below means, okay, here's my little guy. I have a little stick figure, okay. If he's able to walk along the line with his head above the line, that means that's above. If he is under the line, then that means it's below. Okay, so right now it's under the line, his head is below the line. This one, his head's above the line. So I would shade in the area below, which means all of this area below the line. So my solutions can be anywhere along that line. So I can along the line or in the shaded region. So this is a solution, this might be a solution, this might be a solution, this up here might be a solution. Any point in the shaded region is a solution. So if we pick a point, I picked negative 3, negative 3. So let's find where negative 3, negative 3 is. So here, I picked this point right here. Check to see, is that a solution? It's in the shaded region. It says it should be a solution, but is it really? So we're going to go over here, and we're going to plug it into our equation and check to see if that works. So the equation, y, so I'm going to put in negative 3 for y, is less than or equal to negative times negative 3 minus 4. So I'm plugging in my y and my x to see if it works, the one that I picked. Okay, I picked negative 3, negative 3. I want to make sure that I shaded correctly, so I'm going to check to see if I did. All right, negative 3 is less than or equal to, negative times a negative changes to positive 3 minus 4. Negative 3 is less than or equal to negative 1. Yes, that is true. So I can say that negative 3 is a solution, so I know my graph is correct. Okay, so that works. All right, let's try some graphing out. One of the biggest things that you need to remember, and this is going to be on your homework, it's not in your notes. I need to actually remember to put one on there because I didn't. Okay, one of the things that we need to remember is to flip the inequality if you multiply or divide by a negative number. So when we're solving and we're putting it into slope-intercept form, if we have to divide the y value by a negative number, we need to flip the inequality. Okay, if we don't flip the inequality, our graph is going to be wrong, and we are not going to have a correct graph. Okay, so looking at number 1, first thing I'm going to do is check to see what my inequality is. It's less than or equal to. So I'm going to write solid and below. I know that it's a horizontal line because if I write y equal to 2, I'm going to have a horizontal line at 2. So I'm going to plot my point at 2 on the y-axis. It's a solid line, so I drew my solid line. And I have to shade below. So I took and I shaded everything below my line. Now, if I were to pick any point, I could pick any point that's in the shaded region. I could pick any point on the line, and any of those are going to tell me if I graphed correctly. So if I plug those points in, it's going to say. So let's look. Y is less than or equal to 2. Say I picked negative 4, 0. So negative 4, comma 0, check. So it doesn't have an x value in my equation. It only has y is less than or equal to 2, so I'm only going to look at the y value. 0 is less than or equal to 2. Is that true? Yes, that is true. So I can say that my equation is correct. My line, my drawing, my graph, everything is correct because I have the correct shading and I have the graph in the right spot. Okay? I have the shading in the right spot. All right, take a couple minutes and try to graph 2, 3, and 4. Remember, you need to put it into slope-intercept form first. So if we look at number 3, you need to change that to slope-intercept form before you can graph it. Okay, so if I put it into slope-intercept form, I would add x to both sides. So I'm going to get y is greater than 1/2 x plus 1. Okay. Now I'm going to graph it. It's a dotted line, so I want to clearly make sure, if you can see my lines right here, you can clearly see that this is a dotted line. Okay. So you want to make sure that you clearly see that that's dotted, and it has to be shaded above because it's greater than. My equation is 1/2 x plus 1, so I'm going to graph it. I'm going to draw a dotted line, and I'm going to shade everything above. So my graph should look like this. All right, take a minute, pause the video, and do number 2, the one that is below number 1, so this one, number 2. Okay, so take a minute to do that one. So pause it now. See if you can graph it all on your own. Make sure you're on the right track. All right, and then check your work with mine. You should have a solid line. It should be dotted. It should have a negative slope. It should be shaded below. So when you graph it, your graph should look just like mine. All right, number 4 is a little bit different because we can't determine what's above or below. Because we have x is greater than 3, we know that x equal to 3 is a vertical line. So when we graph the vertical line, okay, we're going to have something that looks like this. Because it's dotted, it's greater than, so it's a dotted line, so we're going to make our nice dotted or dashed line. And it's greater than, so it would make sense that all the values that are greater than 3 have to be to the right. So this one's not above or below, this one is to the right or left. Okay, and in this case, above means to the right. Okay, so that one goes to the right. If it was less than, it would be all the values to the left. You would have shaded all the left side. So this is the special case where you have to really read the inequality sign to determine if it's going to be shaded, where the shading is going to be at. If it's greater than, it's shaded to the right. If it's less than, it's everything to the left. All right, so really we haven't learned anything new except our shading and our lines. Okay, so it's very similar to our open and closed circle when we did inequalities before, except now we're looking at linear graphs. So we're graphing it on with straight lines. All right, looking at the last part, example 3. Student government is selling class t-shirts and glow sticks at the homecoming game. T-shirts are $20 each and glow sticks are $2 each. In order to cover the cost of supplies, they need at least $900. So at least, remember, is the inequality x is greater than or equal to $900. It already defined our variables. It says use x as the number of t-shirts and let y equal the number of glow sticks sold. So now we're going to write and graph an inequality. So when we write our inequality, we should have 20 times x, because that's the number of t-shirts, plus 2 times y, which is the number of glow sticks, has to be greater than or equal to $900. Okay, we could solve this using slope-intercept form. However, when I solve it, I get this. Y is greater than or equal to negative 10x plus 450. But if you look over at your graph, negative 10x is not on there. We can't go down 10 and over 1 because the graph is counted by 50s on the y-axis and by 5s on the x-axis. But I can notice that negative 50 over 5 is equal to negative 10. So I can convert that and make sure that it matches my slope. If I went down 50 and over 5, which means down 1 unit and over 1 unit, that would give me negative 10, okay? Or, so you can graph using slope-intercept form, or the easiest way is to graph using the x and y intercepts. You would have the x-intercept. I would cover up y, solve for x. I get 20x is greater than or equal to 900. And then x is greater than or equal to 45. So I would go over here and I would plot my point at 45 on the x-axis. Okay. Then I would solve for y. 2y is greater than 900. Y is greater than or equal to 450. So I would plot my point up here at 450. And then I would just draw the line. So now I already have my graph. I don't need to worry about a slope because I have my x-intercept, I have my y-intercept. I can plot those points, draw the line. And then I can look to see. It's greater than or equal to. So I know it's going to be a solid line and it's going to be shaded above. So I drew my solid line and I shaded everything above. All right, that is it for today. Okay, actually, sorry, we have to do B. If 30 shirts were sold, what is the maximum number of glow sticks that must be sold to break even? So 30 is representing the t-shirts. That means the x values. I'm going to plug in 30 for x and plug it into my equation and solve. So when I do that, I get y is greater than or equal to 150. So that means 150 glow sticks must be sold for them to break even. Okay? Now the next part, would the student government be able to cover the cost of supplies if they sold 22 t-shirts and 250 glow sticks? So remember, t-shirts is the x value and glow sticks is the y value. So I'm going to put 22 in for x, 250 in for y, and then solve. I come up with 940 is greater than or equal to 900. So yes, that is true. They would be able to cover the cost. So yes, they would cover the cost. All right, now that is it for today. The notes are not that long, so you should be able to get through these and then work on your homework. You have all of the problems on the staple copy that I gave you, so make sure that you're working on that and have that finished when you come in on Thursday. Have a great day. Hope you have a great e-learning day and are able to enjoy some of the day to yourself.